All right, perfect. Okay. What the hell? So let's see, 2 minus 4. Then 8. It's number 9. Ten. What is the length of AB? Is A. Or you could just do that. B, 1 and 3, 1, X, and Z. And then 2 and 3. B, 1 and 3. Z equals T. Y. WZ and Z. Okay, and then number 12. -4, -2. HCX would be negative B over 2A. So the vertex is, let me see what the vertex is. The let's see, 14. Okay, and then this next one. D, 1 and 3 only. Let's say 16. Okay, that's just solving for X. 18, the correct answer is 1 to 5. Thus each of the base of the isosceles triangle on the right has a measure 180 minus 30. 180 minus 30 divided by 2, therefore the measured angle is 1. Minus 30 divided by 2 equals 7, therefore the measured angle more. It's a weird one. Okay, all right. Okay. Hey, Aaron, how you doing, man? Can you hear me? Hello?
Hi.
Hey, how you doing? Yeah,
Good.
I was actually in another meeting, but all right. Did you get a chance to do like the 1 and 2 for like last week? I don't know if you had anything that any questions on those for like section 3 and 4.
No, I don't think so.
Okay.
I did them. I'll go through them this weekend and look at specific ones to see if I
Yeah,
need.
no, like I was just wondering because if you have anything, we'll cover section 4. If you have any questions on those for any of these, but like, you know, after we do this, I'm pretty much gonna focus on like section 3 for all of them.
Mm-hmm.
But then like if you do section 4 and you find something there that we should cover, let me know so that like I can compile a list of problems that we can cover.
Yeah.
Okay. All right. So I guess for today we'll still do section 3 and then we'll just go through these ones. All right. You have these in hand, right? I sent you test number 3.
Yeah, I have it.
Okay. All right. So I guess we'll just do this. So I did take a look at this. I think 1 and 2 practice 1 and 2 for section 3 are not that bad, but I think this one actually they had a bunch of other problems that may be difficult. So we'll cover them slowly. If we don't finish it, we'll we can probably cover them again next time. But
Okay.
all right. So if you look at number 1 here, this is pretty much just a word problem. And every time you have something like this, I would usually just skip to like the question. So the question here is asking, let me just make this not too thick, is this guy. And so it says, if the counselor asks the plaintiff to use a more expensive brand of paint, which of the factors in the experiment would change? So the expression I think is saying is this guy. So, and this is just talking about the a different type of paint. So when you go back to something like this, I would just comprehend what these different factors mean, and then kind of like interpret whether anything will change depending on if you change the brand of paint. So this first one, the N, the number of walls, this is not dependent on what type of paint, right? Like it's still going to be the number of walls, so it won't be N that's going to change. And maybe K. Let's look at K. K is a constant number of units of dollars per square foot. So when it says constant with units of dollars per square foot, this may change because you're changing the type of paint, right? So and this is dollar amount. So more expensive is going to change. So maybe just K. Let's look at the other ones. And then the next one is L is the length of each wall in feet. Kind of similar to the number of walls. It's not going to change. And H is the height. So another dimension one. It's not going to change depending on like what type of paint. So that leaves us with K, right?
Mm-hmm.
Yeah. So something like this is not really math. It's more like, can you, depending on what it's asking, can you interpret it? So yeah. So number 2. This one is typical. We've seen algebra questions before. So what is the value of 6r plus 3, given that you have 3r equals 18? So you just solve for r first, right?
Mm-hmm.
So r equals 6, and then 6r would be 6 plus 3. So 36 plus 3 is 39, yeah?
Mm-hmm.
So it's this guy. All right. This one, this is just testing if you know how to convert an exponent to square root form, like a fractional exponent. So when you do a to the 2/3, that's just anything in the bottom can become the square root, right? Or like a cube root rather.
Yeah.
So something like this, yeah.
Mm-hmm.
And this can be like anything, like 4, whatever it may be. Yeah, something like that.
Mm-hmm.
Sometimes they may ask you something to. For the most part, it's just, can you do this? So the answer here is D. All right, 4. So something like this is another one of those things where you have to like interpret, not really like solve a math problem, but interpret like what it's asking. So it's saying here, which of the following equations is true, given like a bunch of these statements. So I think the things that matter here, if you read this, is just these things: twice the number of states, and then the other one is if 30 states join. So twice the number of states that join, and then 30 states join, right?
Mm-hmm.
So they must be equal because twice the number of states join between, and if 30 states join between, this range of year, then they must be equal, right? So twice the number would be this guy, right?
Yeah.
Because X is the one that joined. So between 1850. So it's twice the number of that. It would be 2X. And then if 30 states join, it'll be that. And then you just look at what you have. So what you have here is this guy. So that's the reason why that's like it. All the other ones, they don't really make sense. So, this one is not the right one because it's not saying 30 times the number that join. And this one is not the right one because it's not half. It's twice the number. This one doesn't make sense, yeah?
Mm-hmm.
Okay. And then for this one right here, it's another algebra one. So, what is the value of x over 5? You can't just flip this. What I would do is solve for x by like cross multiplying.
Mm-hmm.
So 5x plus 20 equals like 15x, yeah? So 5x plus 100 equals 15x, yeah?
Mm-hmm.
And then you just solve for it, whatever. 100 and x, and then x equals 10. And then once you have x, you just plug in same as what you've done. So that's 10 over 5. So the answer is 2, yeah?
Yeah.
Okay. All right. So these ones are not that hard, but there are a couple ones here that are. So this one again is you have given a system of equations, and then you need to find this, x and y, and then what is the value of x minus y. So we'll just plow through it. So we'll do an easy one. Let's see. So we'll do 2x minus 3. I'm just rewriting it. Equals minus 14 times this by 3. And the next one times it by 2. Equals minus 6. So it's going to be 6x minus 9y minus 2, 1, 42. And that's 6x minus 4y minus 12. Yeah, and then you minus this. This cancels out. Plus plus 4y. That's going to be minus 5y. Plus plus, so that's going to be minus 30. So that's going to be y equals 6, right?
Yeah.
And then plug in the whichever equation is easier to solve. Let's see. Let's just do one of them. 3x minus 2, 6 equals minus x. 3x minus 12 equals minus 6. Plus 12 plus 12, 3x equals 6. So x equals 2. And then we'll go back to the equation or whatever they're asking you. What is the value of x minus y? So 2 minus 6, yeah,
Mm-hmm.
is minus 4. And that's your answer, C. So we've done that before, right? All these we've seen already, right?
Yeah.
Okay. Okay, now let's do number 7. This one seemed confusing at first. So like it gives you all this table of x and f of x. So the function of s is defined by a polynomial. Some values of x and f of x are shown in the table above. Which of the following must be a factor of f of x? So what I would do here is just kind of like match them, like whichever, when you plug them in, like if you did this, let's see this one. So if you plugged in 4 minus 2, it doesn't equal 0, right?
Yeah.
Yeah, for A. And then if you did x minus 3, 4 minus 3 doesn't also equal 0, right? Like I would probably just do like these, like one by one, and check them. This one does. 4 minus 4 equals 0, so it might be this one. So x minus 5, 4 minus 5. The other one, this doesn't equal 0 as well. Let me see the other one. So if you did 0 minus 4, because the other ones, if you did 5 minus 2, so it doesn't equal negative 2. 5 minus 4 doesn't also equal negative 2. And then 5 minus 3. 5 minus. Yeah, this one was a little confusing at first. I based some of them. Oh, I see. Here because after 2. F of. Oh, I see what it's saying. Let's do something here. So let's see. So f of 0 is 3. F of 2 equals 1. F of 4 equals 0. F of 5 equals -2. And if you did f of 2, what is the function is f is defined by a polynomial. Some values of what is the must be a factor of f of x. Or equals 0, okay, and then 2. Oh, I see what it's saying. So all of this should be. So actually may or may not be factor of f of x. So this for sure can't be correct because like f of 5 is not 0. And then the f of 2 is not 0. And then there's no information about f of 3, so you can't do this guy. Okay, so in this case, whatever I said in the beginning, it would be this guy because it's the one that when you plug in here. Like if you have 4, then it'll give you 0. Okay. Yeah, like I said, some of these I'll probably we'll see if there's another one like this. It still seems a little weird. Okay, let's move on to 8. All right. Okay, so for this one, it gives you a line. So this line equation is y equals kx plus 4, where k is the constant. And then so it tells you if the line contains or crosses CD, what is the slope of the line? So it's asking for the k, pretty much, right? So when you're given, but then you're not given these values. So I would probably just put them like right here. Whatever you would do is you're given a coordinate, so plug them in here and then solve for k, right? So you have d equals k and then c plus 4 and solve for k. That's really what you have to do. So you have d minus 4 equals kc, and then you divide it by c, right? And then so when you do k equals d minus 4 over c, and that matches a. Yeah?
Yeah.
Okay. Let's look at number 9. Okay, so these ones, from what value? Okay, well, they're going to have no solution. Okay. So when you look at this, and are they parallel? Let me see. Oh, yeah. When it says no solution, you can pretty much say, and there's two, that they don't intersect, right? There's no intersection. So when two lines don't intersect, what are they then?
Parallel.
Yeah. So that's like something that you had to know ahead of time. So there's no solution to say they're parallel, which means that their slopes are the same, right?
Yeah.
So 1 and 2. So m of 1 equals m of 2. That's what they're trying to test. So in that case, the first thing I would do is these are standard form, so make them slope intercept form. So the first one here is, let's see, minus 3y equals minus kx plus 4, and you divide this by -3y, and then so that's So that's oops, k over 3 x minus 4/3. Okay, so that's the first one. And then the second one here is minus 5y equals minus 4x plus 7 divided by negative 5. So y equals 4/5 x minus 7/5. And after that, let's see. Then after that, so your k, right? Or this guy right here, your m, k over 3, has to equal this guy, right? From what we said.
Mm-hmm.
And then you solve for k. So k here equals 12 over 5. And that's what we get, 12 over 5. All right. Does that one make sense? That one is just applying, no intersecting is parallel and then solving on algebra.
Yeah.
Yeah. Okay. Number 10. So this one, now there's a bunch of things here where you have to because there's parabolas now. So if you remember your parabolas, so in the parabola equation is this guy. So let's minus 11 squared intersects the line with the equation y equals 25 at 2 points. So let's see. So it's kind of like, I guess there's a line here, and there's this parabola, right? And there's 2 points right there, right?
Mm-hmm.
If you had to do and picture this in your mind, and then you have to get these 2 points. So you already know that your y for these 2 points is 25, and then 25. So you only need to get x1 and x2. So for this, let's see how you get those ones. Oh yeah, since the y equals 25 in essence, just plug it in and solve for x. So x minus 11 squared, right? And then take the square root 5 x minus 11, or plus or minus 11. So x1 gives you, if it's positive, so positive. The other one is negative. X minus 11. So x1 is plus, so that's 16. And x2 is plus 11. That's going to be 6. So these are your two x's in here. So our 2 points are 16, 25 and 6, 25, right?
Mm-hmm.
And then now let's go back to the question. So what is the length of AB? So this is point A and this is point B, right?
Yeah.
That's what it says. And it wants you to find the length. You could just apply, your distance formula, or mentally just look at it. Since your y, they're on the same level pretty much, right? I would probably just if you have to remember all those equations, it's not that bad. Just apply the distance formula, which is just the x's squared minus the y's. So x1 squared plus y2 y1 squared. Yeah.
Mm-hmm.
So when you do that, well, obviously the y, this part cancels out because it's the same. So you're only left with this guy, the 16 minus 6 squared, cancel. So you're obviously it's going to be the same thing as if you were to do it mentally. 16 minus, so it's 10, right?
Yeah.
Yeah. So the answer here is 10. So it's just really applying, do you know what the question is asking you? And then it's either, if you didn't know this, then you could just plug in the 25. And finding the length of something is just applying the distance formula, right? Okay. So let's see. All right, next one. Or not this one, the next one up top. So this next one is they like doing this sometimes where you have like 3 things or 2 or 3 or 4 things, and then And then you have to know, and you have to find like, are they all true or some of them are true, whichever one. And then how you would do it is you just have to like kind of like read through the problem and see if you can figure out which ones are true. So for this first one, so let's just look at it. In the figure above, lines K, L, and M intersect at a point. If x plus y equals u plus w, which of the following must be true? So for the first one, let's look at the first one if it's true. So since the angles marked y and u are vertical angles, this y and u, right?
Mhm.
They're on opposite sides, they're vertical angles. What does that mean? That means they're the same, right?
Yeah.
So subtracting the sides of y of u from the corresponding sides of x plus y gives you, since they're the same, and you're given this equation, yeah?
Mhm.
So since y and u are the same, it cancels, and you're just left with x equals w, right?
Yeah.
All right, so let's see. From that, since the angles marked w and z are vertical angles, so w and z are vertical angles as well, w and z, right?
Mhm.
So that means they're equal. So w equals z, right?
Mhm.
So because of that, you can pretty much plug in where, this w for z. So x equals z then, right?
Mhm.
Yeah, so this is true. The first one is true.
Okay.
And that's how you like pretty much, and now what I would do just to mark, that while you're trying to debunk them, which one is true, just check them. So that's the first one. So now let's look at the second one. Second one. For this one, if you had, and a lot of this is just pretty much, like if you remember geometry and you had proofs and stuff, if there have to be they always have to be, everything has to be true. If for it to be true, if one counterexample isn't true, then that must mean it's false. So let's see if this works every time. So let's see. I guess let's take a look at this example. This is a counterexample. Let's take, for example, if this is an if one. If x equals w equals z equals t equals 70. Yeah.
Mhm.
And then you have this other case, y equals u equals 40. Then all three pairs of the vertical angles in the figure have equal measure. And the given condition. And so from all this, you can say that x plus y, u plus w. This holds because, let's see if it does, because that's what it's given you. So let's see, because this is how we figure out like these values. X plus y, that's 110. And then u plus w is also 110, right?
Mhm.
So that holds. But then let's figure out if y has to be w every time. So it only works for this case, right?
Mhm.
Because let's see, x and u. Because yeah, so like y and w, they're not equal. Because y is 40 and w is 70, right?
Yeah.
So this doesn't hold, but this holds. Whatever
Mhm.
they told you. So this is a counter example, which means then that if this and you have this, then that must mean it's false. This thing is false because you found a counter example.
Yeah.
There's multiple other ones that you can figure out, but this is one of them. All right. So sometimes like these types of problems, I would probably put them in the less because they do take a while. Sometimes you can convince yourself like, oh, is it true? Is it not true? Okay, let's look at the third one. Since the top three angles in the figure form a straight angle, then let me see, x, y, and z. Oh yeah. So if you take a look at this guy, you could have this guy or this guy, right? I mean, this is 360, but then the opposite sides of it, like x plus y plus z, or W plus U plus T.
Mm-hmm.
These are all 180, right?
Yeah.
All right, so since that's 180 and similarly 180, so that means they're equal, right?
Mm-hmm.
So W plus U plus T, they're equal. And let's see. And then, so that's your other equation, but you also have this other equation. Yeah?
Yeah.
So just plug them in and then try to cancel something from the other equation. So since this is equal, that must mean that this and this can cancel, yeah?
Yeah. So that means they're equal.
And in general, because you could do this, and I mean, you could probably figure out a counterexample. I don't think there is one. So that must mean they're equal. And then so in the end, you figured out that it's only 1 and 3. So which one is that one? It's this guy, B. Yeah? Yeah. Yeah, like I said, so for those ones, it's not bad. If you like doing all, proofs are good. Some people don't, they like it, or like, when you try to figure out like counterexamples, but sometimes it's not, so great for others. So if you like doing that, then I would, you could breeze through it. But if not, I would do that last.
Yeah.
All right. So 12. Let's look at this one. So another parabola. So you have this parabolic equation, and it crosses the x-axis. Let's see. Let's see where it crosses the x-axis. It would be -4 and 0, right? Because you have, if you put 0 for y, and you make this, and I think a is, yeah, so x plus 4, this gives you that this one is -4 and 0. That's 1, x-intercept, and then the other one gives you the other guy, which is 2 and 0, right? Yeah?
Mm-hmm.
Do you remember doing this? Like something similar to this?
Yeah, I think so.
Okay. So you have your zeros, and then the graph of the equation x, y, and y with vertex C and D. And then the question is like, which of the following is equal to D? So you have this vertex, it's like C and D. Sometimes it's like H and K. And then and it says here that, so you have, and if you picture this in your mind, this vertex, because the vertex, let me see, so was it 2 and 0? Yeah, 2 and 0. So 1, 2, 3, 4, -4, and 1, 2. It was something like this because it's positive. And then the vertex here is the H and K, right? Or C and D. So this is halfway. Halfway this -4, -2, right? For the x, yeah.
Yeah.
So this C is -4 plus 2 divided by 2, right?
Yeah.
Because halfway. So that's -2 divided by 2, so it gives you -1. So you got C. Okay, and then what about? Let's see this one. Oh yeah, to get the D, you just plug it in to the equation because this is the Y. This is the X. You have to figure out the Y. So let's see. So Y equals A. That's going to be -1 minus 2, and then -1 plus 4. So yeah, Y, and this is -3. This is going to be 3. So Y equals -9A, yeah? In this case. But then this Y right here, actually, like, to not confuse you, because like we plugged in the C, so this has to be D, right?
Mm-hmm.
And this is what it's asking you. Which of the following is equal to D? The Y coordinate of your vertex. So as long as you can point things around, like, like what are they, and then just doing the math. I think this isn't that bad. So this is the answer, -9a, which is a. Yeah.
Yeah.
Okay. Yeah. So they kind of threw the parabola questions in this test, but yeah, if those are good, you don't have to study it as much. But then if you think you need to review those, I think mainly like knowing how to get the vertex. Maybe if you need to solve for the x and y intercepts, you can review those. And then I think if I remember, there's like another form of the parabola equation. Maybe doing those as well. All right, 13. All right, so this one, you have this equation, and it's true for all values x that's not equal to a, where a is, what is the value of a? All right. So let's look at this. Let's see. So -8x3 with remainder. So this is actually a remainder. So this is actually a remainder, right?
Mm-hmm.
Like, because if you did, it's kind of like what you would do here, like kind of like if you did this the long division way. So it would be like this guy, -3, and then you'll get remainder, obviously, somehow. All right, so if you did that, a way to do this is, because you need to figure out what a is, then you could just do this, because you know that's only the remainder, right?
Mm-hmm.
So if that's only the remainder, you can actually minus the remainder here. So equals the 24x squared plus 25x minus 47. Let's erase this so we have more room. Let's see. Yep. Let me see if I can use another form of this to make this make sense. So if you times this whole thing by ax minus 2, yeah?
Yeah.
And then you're going to get this equation, right?
Mm-hmm.
Yeah. So that's another way. But then you could always think about it that it's a remainder, so you can minus it that way. So after you do that, then you distribute this guy, and then you get minus 8x or 8. Let's look at this. Minus 8ax squared minus 16 or plus 16x minus 3ax plus 6 minus 53 equals 24x squared plus 25x minus 47. And then you just solve for a. So let's see, minus 16x minus 3ax. This guy right here is 6 minus 53. That's, let me see, so the 3, that's 47. Oh, and then you just pretty much match what the a is. So, okay, so let me rewrite this another way so you can see what the a is. X minus 47, 24x squared plus 25x minus 47. And then so let's see. Okay, so you could use this right here, right? This is a trick that we did last time.
Mm-hmm.
Whatever's in front of any of these this polynomials, the coefficients, they can be equal if they're equal. So you can make this equal and then solve for a, and you get -3, right?
Yeah.
This one right here doesn't. I wouldn't work with this. You could technically work with this, but you have to deal with the 16. I think. Let me see if you can. It's 3a plus 16 equals 25. Minus 16, minus 16. Okay, 3a. It's the same thing. Either way. So that should give you minus 3, which is the same as the other guy. And what was it asking you? Yeah, it was asking you for this. So either one works. So it's that. So yeah. But does that make sense when you do something like this? You could just get the full equation and then match their coefficients. That's something they like to do a lot.
Okay, yeah.
You just have to like expand the equation to see what you can match. That's the trick to it. All right, so let's do number 14. All right, what are the solutions to this guy? So this is a polynomial, right?
Yeah.
Quadratic equation or a quadratic. So you could use the quadratic equation. So like I said, they like to do those. So I would just remember what it is. So it's like b squared minus 4ac over 2a, right?
Yeah.
And your a, b, and c here are 3, 12, and 6. So let me see. So I mean, it seems like they're not asking you for the actual value, the exact value. So I will just plug in the number and see if you can simplify it. Minus 12. And let's see, 12. Oh yeah, the very first thing I would do to make life easy is just divide everything by 3. So 3x squared plus 4x plus 2 equals 0. A, B, and C, 1, 4, 2. So minus 4 plus or minus 4 squared, that's 16 minus 4, 1, and 2. 2 times 1, and C minus 4 plus or minus 16 minus 8 divided by 2. Minus 4 plus or minus 8 divided by 2. Let's see. Minus 2 plus or minus, let's see. Oh, yeah. So this guy right here can be, so that's 4 and 2, so 2 root 2. So that's minus 2 root 2. That's the answer. Yeah? Okay. So not that bad. Just knowing the quadratic formula or equation, and then from that, just simplify. All right, let's look at number 15. So this one, like another one of those things that you have to prove if it's true or not. So let's take a look at it. So this is the conversion equation from Celsius, Fahrenheit to Celsius. You've probably seen this before, but then let's see what number 1 is. So a temperature increase of 1 degree Fahrenheit. So let's plug that in. 132 is equivalent to the temperature increase of 5/9. Temperature so an increase. So 1 minus 32. Let me see this one. This is what it's saying. So minus 31. Let's see. Oh, I see what you're saying. Temperature increase of 1 degree Fahrenheit is equivalent to a temperature increase of 5/9 Celsius. See the glass. Oh, that's what I'm saying. Increase of it. Okay. So sometimes when you see something like this, you would just look at this as like a slope, right? This is kind of like a slope, right?
Yeah.
5/9 F minus 5/9 32. Yeah. So the slope. What is the definition of a slope? So it's pretty much y equals x, right?
Yeah.
Y here is Celsius. So let's do some, and this is equivalent to this guy, right? 5/9 over 1.
Mm-hmm.
Yeah. So it's y over f, rise over run. Y meaning Celsius and f meaning Fahrenheit, right?
Mm-hmm.
And let's reinterpret what this says and then try to match this equation. So a temperature increase of 1 degree, right,
Yep.
is equivalent to a temperature increase of 5/9, right?
Mm-hmm.
Yeah, I would attack it this way. If you did it another way, you're probably like, okay, one is wrong. Every time they do something like this, like a temperature increase in temperature, and they give you like some like a linear equation, then I would create the slope and which is this whatever the slope number is, you could always make it over 1, and that's just a trick. And then go back to the statement and prove to yourself that it's true. So in this case, it's true, right?
Mm-hmm.
Okay. Yeah. So the first time I did it, don't do it that way because it will be false. Because you're gonna be like, okay, C doesn't seem like it's a because it'll be 1 minus 30, 5/9 times minus 31, which isn't what you're looking for.
Wait, so could you rearrange the equation, like divide by
Like this guy.
5/9 or multiply by the reciprocal on both sides, and then add
And
30 to both sides, and then see if it matched up?
add 32
Yeah.
like this.
Yeah.
Okay, and then what?
Temperature of 1 degree Fahrenheit.
It's a little. You could see that this is 1 right here, right?
Mm-hmm.
Because this thing that every time there, like I said, if you do, and what would you do after this? That's if you did it the the second way I did it. It's easier to interpret this first one. For the most part, this is usually what they want you to do. There's another. It involves statistics, which is like another topic. But then every time they tell you something about something increasing over something decreasing, or like whatever. You usually look at the slope or the gradient. Because if you do it this way, then like it won't
Wait,
match up. Yeah.
wait. So could you then substitute 5/9 to see if it, and then put in a random number to see if it goes up by 1?
Let me see. Oh, that's what you're saying.
Yeah.
So 5/9. Yeah, you could do it that way. Yeah.
Okay.
And then this would be 33, right?
Yeah.
Yeah, and then the increase I think the way I would probably do it is if it's minus, I guess you could look for the gradient, like the actual gradient. So minus like f, something like that. Yeah, for the most part, like you could do it that like the way I've been used to doing this is just looking at the slope.
Mm-hmm.
But if whatever you're saying makes sense, you could do it that way as well.
Okay.
Okay. All right. Let's look at number 2. So for this one, a temperature increase of 1 degree Celsius is equivalent to. So this one, so let's see, increases of 1 degree is equivalent to a temperature increase of 1.8. So 1.8 looks like 9. Yeah. So this one is the opposite of the other guy. So if you change it, so let's say 9/5 C plus 32 is this guy. And then so 9/5 over 1, this is F, and then this is C. Let me think. How come? Okay, so this one would be the same. Oh, okay, yeah. So it'll be the same, right? It'll be true because an increase in Celsius right here would give you 9/5 or 1.8. Yeah.
Mm-hmm.
So this one's true as well. True, true. All right. Let's look at number 3. A temperature increase of 5/9 degree Fahrenheit is equivalent to the temperature increase of 1 degree Celsius. So it's either 1 or 2 are correct, and this third one might be wrong, right? Because they're pretty much switching it. Let's just see 5/9 degree of the Fahrenheit. Let's look at the one that matches that one. It would be this guy. Yeah.
Mm-hmm.
So it's either 1 or 3 is correct. But since 1 is correct, 3 can't be correct, right?
Mm-hmm.
Yeah. So it's D. Yeah. So for those ones, this one isn't that bad. I think the other one was because you could just plug in and figure it out. All right. Let's see if we can finish this. So 16. So now we're in the fill-ins. So this one you can have multiple solutions. What I would do is just typical solve for x. So let's try expanding this. So let's see. Okay. So if you do this with x to the 5th minus 5x cubed, and then equals minus 4x, and then x 5th, 5x cubed plus 4x equals 0. And then from that, factor out x, or what is least? So I think it is x to the 4th minus 5x squared plus 4 equals 0. And it's keep in mind what you have here. And then so x equals 0 is a solution, but it's not greater than 0. So it's probably going to be this one inside that's going to give you the answer. So when you expand this and then factor it, x squared minus 1, x squared minus 4. And then this first one right here gives you x equals negative or positive or negative 1, right?
Mm-hmm.
And this next one is x equals positive or negative 2. Yeah? But then it's only the positive ones that you want.
Okay.
So it's only 1 or 2.
Okay.
And I think that's the answer. Either one of those guys. The other way of doing it is just probably plugging in some values, see if it works. Because you only need one of them, right? So it gives you that it has to be greater than 0. So the next integer would be 1. Plug that in. I think that's the fastest way instead of solving for it.
Yeah.
And 17. What is the value of x? This one again, you just have to solve for it. And then what it would do is just clear the fractions first. So let's see. If you do that, you're gonna get 28x minus 16x equals 9 plus 15. After all the simplification. And then when you do that combined like terms, you're gonna get 12x equals 24, obviously, divided by 12. X equals 2, yeah? That one's the easy one. All right. So let's take a look at this other guy, number 18. Okay. Number 18. So this one is actually pretty long. Maybe we'll end with this one. What happened? Okay. Yeah, here we go. All right, so with this guy, it's another geometry one. Two isosceles triangle is shown if y 180 minus z equals 2y and y equals 75, what is the value of x? So what is the value of this guy? All right, so since you have 180 minus z equals 150, so you can solve for, once you have, let me just write the first one down. Z equals 2y, so that's 2 times 75, which is 150. And then from this, you get z equals 30, right?
Mm-hmm.
And thus each of the base angles are, so this guy is this guy, and then since this is the same as this guy, and that must mean this angle is the same as that guy, right?
Yep.
So that's going to be 180 minus 30 divided by 2 gives you 75. So that's, this is 30, and this is 75, and this is 75. And then after that, this guy right here is supplementary. So it's just 180 minus 75, right?
Yeah.
Gives you 105. All right. Okay, I guess we still have time. And that's the answer. So let me see. Number 19. Okay, I think this is the long one. So let me see. So this one, let's just see what it says. How many calories does a hamburger have? Okay. And then so you have to write a bunch of equations. First thing you should write is this guy, 2f plus, I guess, 100. Let me see first. Yeah, it's a bunch of equations. So 2h plus 3f equals 1700. That's like one of the first ones. And the equation represents the fact that, and then the other one it says h equals f plus 50, which is this first one. And then so you just plug in this guy in here. See, so, and then you get 2f plus 100 plus 3f equals 1700. So that's 5f equals 1600. So f equals 320, right?
Yeah.
And it was a question, how many calories does a hamburger have? And then so plug that back in here, and you're gonna get 370, right?
Yeah.
Yeah. All right, almost done. 20. All right, let's see if we can do this really fast. In triangle ABC, the measure B is 90 degrees. Thus AC is and BC equals 16, AC equals 20. Okay. So let me actually skip through what you will have to do. So Pythagorean theorem tells you, because you have this thing, I think B is, this is 90. So this is B, and then let's see, C and A. Let's see, what is it? 20. Which one is the hypotenuse here? AC is the hypotenuse. And AC is 20. BC is 16. Okay. And then after doing the Pythagorean theorem, you're going to get that this is 12, right?
Mm-hmm.
Which is just 20 squared, this guy. And after that, let's see. So since triangle DF is similar to triangle, so you have this DF, which is similar to ABC. It could be big, whatever, DEF. And then it's saying that the sine of F is the same as, so he said from the sides of the length, what is the sine of F, right? That's what it's wanting you to do.
Mm-hmm.
So since they're similar, then it has to be the same as sine of C, right?
Mm-hmm.
So what is the sine of C? The sine of C is AB over AC, right?
Yeah.
Which is 12 over 20. And then this is 3/5. So that's the answer. Yeah?
Yeah.
Okay. All right. So I think that's good. 1 minute over. But yeah, for the next one, just do this for homework. And then, yeah, please send me questions about it. And we'll do number 4 next time, test 4. All right. Aaron, thanks, man.